Howdy doody, Science Tenerinos. Well, we just want to take a look at some formation reactions here for a second. So I went into the lab earlier and I recorded some formation reactions for you, and hopefully you enjoy them. We're going to take a look at them. The first demo is a reaction between aluminium and iodine. And we're going to take a look at the video. We're going to see it, and we're going to analyze what's going on. We're going to figure out, is it endothermic, is it exothermic? And then we're going to try and write the chemical reaction for it. So let's go ahead and watch the first reaction. It's a couple minutes long, but let's go ahead and watch the first reaction, and then we'll come back and then we'll write down the chemical reaction for it. So in the reaction you just saw, we took the aluminium and reacted it with the iodine, and you can see the iodine is actually making the paper start to turn a little bit yellowish brown. And it made, well, it made this white kind of salty looking substance here. And that's really characteristic of a lot of ionic compounds. A lot of ionic compounds are just a white solid. They're kind of indistinguishable. So we're trying to figure out, what is it, the thing that we just made? Okay, that reaction was, I don't know, it was a pretty cool reaction. Some really deep purple smoke going on, and a couple points in time we saw a white, some white smoke coming off of it. And I don't know if you saw, after the evaporating dish broke in half because of how much heat was produced, there was a white solid substance left at the beginning, left at the end. So let's go ahead and try and figure that out, and let's try and write the chemical reaction. First question I have for you is, was this reaction, was it endothermic or was it exothermic? So was this reaction exo or endothermic? Because an exothermic reaction is a reaction that releases heat to its surroundings, and an endothermic reaction is a reaction that absorbs heat from its surroundings. Okay, we'll talk about that here in a second, but let's try and write this out. Remember, if you want to try and predict what a reaction is going to do, you should think about the words. So we've got aluminium reacting with iodine. And the only thing that we can really produce is, well, metal, non-metal. So this is going to make aluminium iodide. This is a formation reaction. It's going to make aluminium iodide. Whoa, that's terrible. Uh-oh. Okay, so let's go ahead and make a chemical reaction for this. Aluminium is an element, and it's not part of Hofbrinkel, so we're just going to say Al solid. And it's going to react with iodine. Iodine is an element, and it is part of Hofbrinkel. All right, so it's reacting with I2, and it's a solid. And this thing is going to make aluminium iodide. Aluminium iodide is an ionic compound. Aluminium iodide, aluminium is 3 plus, iodide is 1 minus. So we need 1 aluminum or aluminium and 3 iodides. Perfect. So now we've got our skeleton reaction. We haven't balanced it yet, but we've got our skeleton reaction. So 1 aluminium is not going to react with 1 iodine to make Ali3. That's not going to work. So let's go ahead and balance this reaction. The most complicated element in here is iodine, because you got 3s and 2s. So we'll need 3s and 2s and 2s. So the way I did that is I knew that 2 and 3 have a lowest common multiple of 6. So I need 6 iodines here and there in the reactants and in the products. And because I have 2 aluminium iodides, then I need 2 aluminiums. Perfect, no problem. So that was the first reaction. And to answer our question, was it endothermic or exothermic? This is most definitely, I mean, hopefully you saw the flame during the reaction. Hopefully you saw the glowing white hot substance at the bottom of the evaporating dish after it had already cracked the dish open. So yeah, absolutely. This was an exothermic reaction. Just important to keep in mind. Okay, let's move on to the second demo. Now, the second demo is a reaction between magnesium and oxygen. It's a pretty quick video. Let's go ahead and watch the video, and then we'll talk about whether it's endothermic or exothermic, and we'll also write down the chemical reaction. Whoa, that was a pretty interesting chemical reaction too. Sorry, I'm not trying to be patronizing. When I watched that video, I think that's pretty cool. So let's take a look at that reaction between magnesium and oxygen. And okay, magnesium is a metal, oxygen is a non-metal. So 2 elements coming together, they are going to make an ionic compound. They're going to make magnesium oxide. That's the only thing that they can make. So let's go ahead and write down the formulas for magnesium oxide. Magnesium, oxygen, and magnesium oxide. So magnesium element, not part of Hofbrinkel. Mg solid. Perfect. Oxygen is part of Hofbrinkel, and it's an element, right? So O2 gas. And when it gets made, magnesium's 2 plus ion, oxide is a 2 minus ion. So we just need 1 of each, and it's an ionic compound, so it's going to make a solid. Okay, so we got magnesium oxide being made from magnesium and oxygen. That seems fairly straightforward. Let's go ahead and balance this. 2 oxygens, we need 2 oxygens. 2 magnesiums, we need 2 magnesiums. Perfect. Now the last question, is this reaction endothermic or exothermic? Well, hopefully you saw the light being produced off of this substance or off this reaction. This was also exothermic. Exothermic reactions are the more fun reactions to be able to record. Okay, so the white kind of ribbon that was left, the white solid that was dangling from the utility clamp at the end of the video, that was the magnesium oxide. That was the solid magnesium oxide. So we were reacting a magnesium metal. You should have seen how, it was a little bit shiny and it was metallic looking. It was reacting with the oxygen in the air to produce that white solid, which was magnesium oxide. Hopefully that gives a little bit more context into formation reactions for you. Let me know if you have any questions. There's a Google Doc out there and office hours. Thank you very much. I'll see you later.